Aryan, and this is my video on data link layer and all the error detection and all the important protocols that are there in the data link layer. So let's begin. First of all, let's uh, let's see what are the services that are provided by the data link layer. So first of all, it is the controlling of the flow. So data link layer basically controls the flow and helps in the reducing of the traffic and reducing of the congestion by controlling the flow of the giving the access and every other things. Also, it helps in the EDC, that is the error detection and correction. We have various routing protocols for the error detection and correction. We'll discuss more on that later. Also, we have a MAC protocol here. Now, this MAC protocol is, if I talk in very brief, this MAC protocols are used for giving the access from the router from to the node by the router that wherever the data would be sent or what the link should be established. The next one is the ARP. So ARP basically stands for Address Resolution Protocol. I'll discuss it in detail in the further slides. Now, if I first talk about the technique that I use for the detection and the correction of the error, the first one would be parity check. So basically, uh, when a data is sent, when a datagram is sent, it has two types of bits in it. One is the D bits, and one is the parity bit. So that parity bit is known as the EDC bit. So D bit stands for the data bit, and parity bit stands for the error detection and correction bit. So what happens when the data is sent, that p bit, that whole bits convert into e dash and edc dash. I'll talk that about later. But this e bit, sorry, that d bit and that edc bit, basically in the in the d bit we have all the data that we want to send, and in the e bit we have an extra parity. So what is a parity? So parity basically means that we are adding up a new bit to make all the ones either even or odd. Now, whenever we add a one to make all the ones odd or even according to our needs, we send it to the receiver where it is converted into D dash and EDC dash. So basically, the parity is recalculated over there, and if the both the parities match of the receiving end and the one that is being sent by the router, then we say that there is no error and everything, the data is transferred as a whole. But if there's an error, the error would be that the parity didn't meet the required conditions. Like for example, there should be even number of ones, but there are not even number of ones. Instead, there are odd number of ones. So that's why we get to know that there is an error. Now, the parity check is of two types: single parity and graph parity. So that is the two-dimensional parity. So two-dimensional parity is more precise, where we get to know about what the error is and where the error is, because we add a parity at the end of each row and column. So that's why it is more precise in the table, in the matrix format, basically. If I talk about the next thing, that is the checksum. So this checksum basically involves summing up of all the bits, and basically that would be a one complement addition, summing up all of them and then taking its one's complement and sending it to the receiver. Then when the receiver receives it, it basically uh, complements it again, does its one complement again, and then compares the result, the sum, the checksum result. That if the sum matches with the one that is being sent, then we get to know that okay, there is no error. But if it doesn't, the error is there. Now this redundancy check, that is CRC, is basically the same thing. So what happens in CRC is that we do the same thing, but there is a predefined integer, the predefined polynomial, a bit polynomial, which with the help of which we perform a long division on our bytes. So like for example, there would be any predefined polynomial bit, uh, and we'll divide the whole bit, the data we want to send, by that predefined polynomial, that is the CRC polynomial. Now, uh, when we send the data, and we again will check by dividing that bit that is received on the receiver end by that same predefined polynomial, If the long division method, the remainder comes same. By the long division method, if the remainder comes same, then we get to know that there's no error. Otherwise, if there's a change in the remainder, we are sure that okay, an error occurred, and we need to check what happened. Multiple access protocol. So what is multiple access protocol, and why do we need it? First of all, so what happened was that on a router, whenever the nodes used to send data, so the node used to send two or three data simultaneously, that would cause collision and will cause traffic on the router's end, and router would was not able to pick any of the request that is sent by the node. So to counter it, we give access to them, that which uh, which basically request should the router catch first, and they give access to first on the priority basis of priority. There are certain rules. So basically, a multiple access protocols are all the set of the rules and procedure that that are used to coordinate between these devices and the multiple users, so that we can basically provide a we can use a shared connection and a shared medium like a wireless channel. Okay, so it is basically used for the removal of collision. So there are three type of MAC protocols. That one is the channel partitioning, then we have random access, then we have taking turns. If I talk about channel partitioning, we have two further more categories in this. That is TDMA, time division time division message access, and FDMA, that is frequency division message access. So basically, the time division message access is basically the data is sent on the basis of time and a certain round. So it is sent periodically after a certain time limit. So first I can send the data, and I have to wait for some time. In that time when I have to wait or basically sleep, the other node can send their data, and after every the time is complete, or basically other nodes are done sending their data, I can resend my data. Now, the thing in this is that the ideal uh, the unsigned bits are basically set idle, or basically they are not filled up. So like for example, if there's a six let's say 6-bit long channel, so in that case, if the 1 2 and 3 are filled, then 4 5 and 6 are in ideal condition, and they are not being transmitted. So that is basically tells us that okay, uh, we are taking basically we are given a specific time to transfer our protocol and to basically send our data in a periodic manner. So first of all, I'll give my data, then my friend can give the data, and when all the classmates are done giving data, I can restart from there giving my data after a certain time gap. So a periodic time gap. This is not about the terms, but it is about the time that will be required. So I'm saying that others can send the data in the next 5 minutes, next 5 seconds, but I'll send it after 5 seconds, and there should not be any collision. Similarly, we have a frequency. There's no such as time thing, but there's a difference in the frequency. So different nodes will operate on different frequencies. If I want to send the data, I can send on, like for example, 128 gigahertz. Someone else can send on 60 gigahertz or something else, and there's no chance of collision. So that's why one is FDMA and one is TDMA. Then we have random access. Now, unlike channel partitioning, there is no such predefined or prior ways of communication, like prior ways of telling that these are the coordination mechanism, and this is how we need to behave and basically tell. But in random access, the access is given just randomly to whatever person they want to, so whatever node. So with that said, the name is random access. So basically, we still have two types in it, that is CSMA CD and CSMA CA. So basically, CD stands for collision detection, and CA stands for collision avoidance. So CD is used in wired channels, and CA is used in wireless channels. CD checks for the collision at the beginning at the first time, and avoids the collision for the rest of the part. But CA avoids the collision at all. It does not. The collision does not occur in CA because it's a wireless medium. It can't afford the collision. At the end, we have a taking turns. So taking turns is the simplest. It is just like giving the tokens. Like for example, I have a flag. I'll give it to my node one. I'll say that okay, now you can send me the data. When you are done sending the data, transfer it to the next person, and the person who's having the flag can now send me the data, and just give it to whoever you want, based on a specific table, and you'll give it. The next When the next person receives the flag, that flag, or basically that token, next person can share the data with me, and when you are also done, you can pass it on to the third one. So that was basically taking turns. Now, what is ARP? So, ARP stands for Address Resolution Protocol. Now, uh, there are certain MAC addresses that are fixed for every device, because the MAC addresses are set during the hardware build-up. Now, what happens is that whenever we basically enter a network and we ask for an IP address, so the router is having our uh, basically the router is having a MAC address, and what happens is that whenever we enter a network, the router says that okay, uh, this is the IP address that I'm searching for, and I want to map the MAC address with this IP address that I'm having. So it broadcasts that IP address, that whichever IP address there are uh, then devices are having, please respond to me. So whenever someone responds, the ARP table gets updated and maps the MAC address with the IP address that is associated. Okay, like for example, if I am having certain MAC address, and the router says the broadcast message that I am having this MAC address, sorry, I'm having this IP address, please tell me which MAC address have this IP address associated with them. So I'll basically kind of raise my hand and say that okay, I'm the one, and you can associate me with it. And it's a three-way process for the LP request to send that which router is carrying that IP address, sorry, which end device is carrying that IP address. Then we have an ERP reply that saying that I am carrying that IP address, and then the table is being updated and the data is being mapped in the cache. Thank you. That is up for my video demonstration. Sorry, that is up for my video. Thank you.